Hello, hello! Now we're going to talk about the grade 9 mathematics curriculum guide. Now, for this one, if you don't know how to read the code, the first one is the subject, so mathematics. The 9 is the grade level. The last two here is mostly the subject type, so we are in algebra, AL, L. The Roman numeral here talks about the quarter. The lowercase letter here is the week, and the number here talks about the learning competency level. So that's how we're going to do it. I might put this in the video so that you'll have a quick way to get into those videos. Well, in some of these, I'll make one for each competency, maybe one or more, depending on how heavy it is. And of course, in most of the subjects, the first quarter in mathematics are the heaviest. First quarter, heaviest. Second quarter, not that much. Third quarter, fourth quarter is mostly your performance task. In the case, let's start. So first one, we're going to illustrate quadratic equations. If you notice that you've been learning in your grade 7 and grade 8, just simple linear equations. Now we're going to up it by a power and we're going to learn about quadratic equations. And in no surprise, in your 10th grade, you're going to talk about up another power up, which is polynomials. I was trying to find the word in. Okay, second one. So we're going to have to solve quadratic equations. Of course, we're always going to have to solve. If we learn something new, we are going to solve it. Mostly by what? By illustrations, by word problems, and so on and so forth. Okay, now we are going to extract the square roots, factoring, completing the square, and using the quadratic formula. The quadratic formula is the go-to way to solve quadratic equations. And in one part of the quadratic formula is there's going to be a very important aspect in it, and we're going to learn it here in the discriminant because the discriminant is inside the quadratic formula. We're going to learn about that in this video. Okay. Now we're going to describe the relationships between coefficients and the roots of a quadratic equation, right? Then we're going to solve it, of course, and then we're going to solve it some more. So we're going to first solve it with equations, then we're going to solve word problems with it. Then a new topic, quadratic inequalities. Of course, every equality, there's going to be some inequalities. Inequalities are a bit trickier, but don't worry, we're going to power through it. First is to illustrate, then to solve it, all in quadratic inequality. And solve again using word problems. Then this one is higher reach because you're going to do some modeling. So models real life situation using the quadratic functions. There's a lot of examples in science. So hopefully we'll be able to integrate some science in it. Then represent a quadratic function using the table of values, the graph, and equation. My go-to would always be the equation. I don't like doing the graph because it's a hassle to draw it. Table of values, yeah, it's bare minimum. Then we're going to transform the quadratic function defined by these equations into this equation, right? And in this one, we can actually form some function. But in this case, this is a equation. I'll make a video soon. Having the difference of equation and function. Then we have here graphs, a quadratic function, domain, range, intercepts, axis of symmetry, vertex, and direction of the opening of the parabola. Because we all know quadratic is it's not a straight line. It's a U shape or an N shape, depending on the opening. Domain and range, you've learned that in your grade 8, and even intercepts. Axis of symmetry, vertex, and direction. is uniquely in the quadratic function, right? And then we have a new one. We're going to analyze the effects of changing. So we're going to manipulate the equation. So if we're going to manipulate the k here, what happens? If we manipulate the h here, what happens? And so on and so forth in a graph, because in you're going to do it algebraically, you won't see anything, just the change in values. But in a graph, something interesting. So I'm excited for this. Then we're going to determine the equation of a quadratic function given the table of values, graph, and its zeros. The zeros is a bit tricky, but don't worry, I'll be there with you. Then now we're going to solve problems involving quadratic function. So 16, more than 16 videos would be on the first quarter, and of course it is heavy. The succeeding quarters, you don't have to worry that much. It's not as heavy as the first quarter, but we're still in algebra. Now, after all of this, what's next? We're going to learn about variations. Direct, inverse, joint, and combined. Variations is easy, so but don't underestimate it. Then we have to translate variation statement, a relation between two quantities given by the table of values, a mathematical equation, a graph, and vice versa. Then, of course, we're going to solve problems involving variation. Then we are going to apply. So this is a new one. Apply the laws involving positive integral exponents to zero and negative integral exponents. And then illustrate expressions with rational exponents, and then simplify expressions with rational exponents. This is like radicals, but in exponents form. Then we're going to write expressions with rational exponents as radicals. Yeah, it's just radicals. It's basically radicals in exponent form. Then we're going to derive the laws of radicals. I like this actually. The laws of radicals, then simplify and perform operations on radical expressions. What are the operations? Those are addition, subtraction, multiplication, and division. Then after that, we are going to solve equations involving radical expressions. And finally, solve some word problems involving radicals. Right? Now we go to the third quarter, in which case we will have a new content, which is geometry. Now we are going to start with quadrilaterals. You know, your squares, rectangles, parallelograms. It is all quadrilaterals. So this is actually a fun topic to teach and even learn. And then we're going to determine the conditions that what makes a quadrilateral a parallelogram. This is properties to find the measures of angles. So this is the math involved in the geometry. Then we're going to prove some theorems. Hopefully you still remember your theorems way back in your grade 8. And we're going to use them in your parallelogram, rectangle, rhombus, square. Then we're going to prove the midline theorem. I don't know why they separated this. This should be right over here in 32. In any case, that's a little comment from mine. Proves theorems on trapezoids and kites. So proving is the bane of a lot of students, so I'll hold your hand in it. Then solve problems involving parallelograms, trapezoids, and kites. Again, more and more. So it's not proving, it's just solving problems. Then we are now going to have a new topic, which is proportion. You should know this way back in your grade 5, I believe. Yeah, it's supposed to be grade 5. Then we're going to have some fun with it. Then we're going to apply fundamental theorems of proportionality to solve problems involving proportions. It's basically two fractions that are equated together. And then we're going to have fun with that. Then we're going to illustrate similarity of figures. So similarity is different from congruence. Similarity is they are similar. I'll get to that when we get to this point. Then of course We have to prove the conditions of similarity of triangles. If you remember your congruency theorems, this is similar, but not really. And then applies the theorems. Then we have to prove the very famous Pythagorean theorem. There are more than one way to prove this, so maybe I'll just pick one famous one, or maybe I'll make a couple proofs for this video. Then finally, we are going to solve problems involving triangles, similarity, and right triangle. And that's it for the third quarter. Now for the fourth and final quarter, we are going to dive into trigonomic functions. I mean, trigonometry basically. So we're going to illustrate the 6 trigonomic ratios: sine, the cosine, the tangent, the secant, cosecant, and cotangent. I'm going to have an insightful video for this because there's a reason why it's called a tangent. There's a reason why it's called a sine. So hopefully I have enough skill to teach that. Then we're going to find the trigonomic ratios of special angles, illustrate the angle of elevation and the angles of depression, uses trigonomic ratios to solve real life, of course, real life problems involving right triangles, illustrate laws of sine and cosines, but why not laws of secant or cosecant? There's a reason for that. And then we're going to solve problems. Of course, we're always going to solve problems because that is half of the learning competency is basically solving stuff. After we learn new things, we're going to solve those things. And that is for the final one. So a total of 48 learning competencies or maybe topics to learn in your school year. So maybe the videos would be 48 or more, and maybe some insightful videos covering some like the trigonomic ratios, the reason why they're called that, maybe some history behind it, and hopefully I'll be able to make the videos alongside while you're learning all of this. In any case, that's it for now. I'll see you right and then.